Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of recursive sequences. This is standard A.12C in the great state of Texas. We are using item number 24 off the Redesign Practice online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a sequence here. Let's open up our graph draw feature. And this sequence here has this equation that we can use here. So what type of sequence is this? Well, there's two different types of sequences. There are geometric sequences. We're not really dealing with that right now. We are dealing with an arithmetic sequence. Now, I know the difference because of how this is constructed. So arithmetic sequences look like this. A to the n equals your a to the n minus 1 plus d. Now they've swapped the two terms. That's fine. So this d is the difference. Okay, so each term in the sequence is going up or down by a common sequence, and it's arithmetic because you're either adding or subtracting. In this case, we're going to end up subtracting, right, because it's going to be a negative 3 plus that term. Now, when we get these things, we always have a few stipulations. Number one, we always need to know what that first term is. Okay, so the first term doesn't always necessarily follow the rule of this a to the n equals a to the n minus 1. So our first term is going to be 5. So if I were to write this as a sequence, a to the 1 means that's that first term equals 5, which means like I'm already getting rid of a and c because the first term isn't 5. And then after that, n has to be whole numbers, okay, has to be greater than 1. So we're not dealing with 1.5 or 1.6. They're just what's the first term, second term, third term, fourth term, fifth term, whole numbers greater than 1, simply because we already know what the first term is. That first term is equal to 5. So once we have that, the rest kind of solves itself. So let's say I want to do I want to take the second term. Okay, so let's say n equals 2. What do we do when n equals 2? Well, a to the 2 equals negative 3, right, plus a, and then I'm going to substitute in that 2 right there. 2 minus 1. Okay, so now we simply simplify. Negative 3 plus a to the 2 minus 1 is just 1. Okay? Well, what is a to the 1? Well, we just figured that out, right? They gave it to us as 5. So our first term is 5, so negative 3 plus 5. So that's going to end up being positive 2. So it's just like we're subtracting 3, right? So even after that, that very first time, right, we've got a diversion here. This d is adding 3, the b is adding negative 3 or subtracting 3. Okay, so it's looking like that b is looking good, but let's see what happens when n equals 3. That means the third term in the sequence. Okay, what happens when we go right there? Well, a to the 3 equals, and then we just copy down again. Negative 3 plus a to the, and then our 3 goes right there where the n would go, minus 1. So negative 3 plus a to the 3 minus 1 makes 2. So we need the second term in the sequence. So negative 3 plus, what's my second term in the sequence? It's going to be 2. So negative 3 plus 2 makes negative 1. All right, and that makes sense. And we're pretty sure it's going to be b, but let's check out that fourth one. When n equals 4, what happens? Well, it's going to be negative 3 plus a to the 4 minus 1. So it's going to be negative 3 plus the previous term, a to the 3. My a to the 3 is negative 1. So negative 3 plus negative 1. It's going to be like negative 3 minus 1, right? And that's obviously going to be negative 4. So this is just a fancy way of saying, look, just subtract 3 each time, because that's what that difference is, and it's an arithmetic sequence. So my answer here is B.